Lesson 5.6. We are now going to talk about inequalities again, but this time in two triangles. Comparing two triangles. The hinge theorem. Take a look at this. It's actually called the hinge theorem, and I know when I was talking about an angle of a triangle in another lesson, I was talking about if you were opening a door, the hinge would be on this side, the opening would get bigger and bigger on the other side. The hinge theorem says if this is an 88-degree angle, can't you tell that this side across from it is going to be way bigger than the side across from a 35-degree angle? It says if this angle is bigger than that angle, then the only possible option is for that side to be bigger than that side. Only if the two sides that you're comparing are congruent. See the tick marks here. You've got a single tick and a single tick, double tick and double tick. So I'm going to use the same pens for both of these. If those are congruent to the other triangle, the bigger the angle is, the bigger the side is across from it. The smaller the angle is, the smaller the side is across from it. And I would say whatever you do not go look up the definition of the hinge theorem, because it says if two sides of one triangle are congruent to two sides of another triangle, and the included angle of the first is larger than the included angle of the second, then the third side of the first is longer than the third side of the second. Oh my gosh, do not write all that down. Common sense says if you spread this angle open, the side is larger. If you close the angle, it's smaller. That's what that is saying, but a picture paints 1,000 words, and that almost has 1,000 words right there. But notice it does say the included angle. We're talking about the angle that's between the two sides. We've done that with triangles before. There is a converse to the hinge theorem. If we can go all the way back to chapter 2 and talk about converses, that's basically saying if the side is bigger, then you know that angle 1 is bigger than angle 2. So it's the reverse order. You know converse. Angle 1 is greater than angle 2. Converse to the hinge theorem says switch the if and the then. Basically saying if the side is bigger, then the angle is also bigger. So if you're trying to figure out how big the third side is, if you're given the angles, you're using the hinge theorem. If you're given the sides, you're using the converse to the hinge theorem. And don't guess on those. Go look them up. Keep your notes. Use the hinge theorem if you're comparing the third side. Use the converse of the hinge theorem if you're comparing the included angle. If you want to know how big the angle is, use the converse. Here's a diagram. We have one pair of congruent sides, two pair of congruent sides due to the reflexive property. We know that this is the included angle between those two sides, and we know that this is the included angle between those two sides. Which angle is bigger? Definitely 24 inches is bigger than 23 inches. It's not much bigger, but this angle down here at angle S is bigger. Don't call it angle S. We've been through this before. I don't know which angle S you're talking about, if you're talking about this one, or the big obtuse one. So how does angle PST, right here, compared to angle SPR up there? Angle PST is bigger, larger, greater, however you want to say it. Did you use the hinge theorem or the converse of the hinge theorem? You could guess and be like, I think that was the hinge theorem. Hold on, go back, look at your notes. If you're comparing the included angle, you are using the converse to the hinge theorem. If you know how big the sides are and you're trying to find how big the angle is, you are using the converse of the hinge theorem. And yeah, it's important to know the difference. We're not doing this big long example unless you're in class. If you're in class with us, we're doing the example. If not, you're good to go. So know the difference and know how to use it. Converse and hinge theorem.